A rooftop photovoltaic power station, or rooftop PV system, is a photovoltaic system that has its electricity generating solar panels mounted on the rooftop of a residential or commercial building or structure. The various components of such a system include photovoltaic modules, mounting systems, cables, solar inverters and other electrical accessories. Rooftop-mounted systems are small compared to ground-mounted photovoltaic power stations with capacities in the megawatt range. Rooftop PV systems on residential buildings typically feature a capacity of about 5 to 20 kilowatts, while those mounted on commercial buildings often reach 100 kilowatts or more. Installation. The urban environment provides a large amount of empty rooftop spaces and can inherently avoid the potential land use and environmental concerns. Estimating rooftop solar insolation is a multifaceted process, as insolation values in rooftops are impacted by the following: time of the year, latitude, weather conditions, roof slope, roof aspect, shading from adjacent buildings and vegetation. There are various methods for calculating potential solar PV roof systems, including the use of LiDAR and orthophotos. Sophisticated models can even determine shading losses over large areas for PV deployment at the municipal level. Feed-in tariff mechanism. In a grid-connected rooftop photovoltaic power station, the generated electricity can be sold to the grid at a price higher than what the grid charges for the consumers. This arrangement provides payback for the investment of the installer. Many consumers from across the world are switching to this mechanism owing to the revenue yielded. The FIT, as it is commonly known, has led to an expansion in the solar PV industry worldwide. Thousands of jobs have been created through this form of subsidy. However, it can produce a bubble effect which can burst when the FIT is removed. It has also increased the ability for localized production and embedded generation, reducing transmission losses through power lines. Hybrid systems. A rooftop photovoltaic power station can be used in conjunction with other power sources like diesel generators, wind turbine, etc. This system is capable of providing a continuous source of power. Advantages. Installers have the right to feed solar electricity into the public grid and hence receive a reasonable premium tariff per generated kilowatt-hour, reflecting the benefits of solar electricity to compensate for the current extra costs of PV electricity. Disadvantages. An electrical power system containing a 10% contribution from PV stations would require a 2.5% increase in load frequency control capacity over a conventional system. The break-even cost for PV power generation is found to be relatively high for contribution levels of less than 10%. Higher proportions of PV power generation gives lower break-even costs, but economic and LFC considerations imposed an upper limit of about 10% on PV contributions to the overall power systems. Technical challenges. There are many technical challenges to integrating large amounts of rooftop PV systems to the power grid. For example, reverse power flow. The electric power grid was not designed for two-way power flow at the distribution level. Distribution feeders are usually designed as a radial system for one-way power flow transmitted over long distances from large centralized generators to customer loads at the end of the distribution feeder. Now, with localized and distributed solar PV generation on rooftops, reverse flow causes power to flow to the substation and transformer, causing significant challenges. This has adverse effects on protection coordination and voltage regulators and protection coordination. Ramp rates. Rapid fluctuations of generation from PV systems due to intermittent clouds cause undesirable levels of voltage variability in the distribution feeder. At high penetration of rooftop PV, this voltage variability reduces the stability of the grid due to transient imbalance in load and generation and causes voltage and frequency to exceed set limits. That is, the centralized generators cannot ramp fast enough to match the variability of the PV systems, causing frequency mismatch on the whole system. This could lead to blackouts. This is an example of how a simple localized rooftop PV system can affect the whole power grid. Cost. Future prospects. The Jawaharlal Nehru National Solar Mission of the Indian government is planning to install utility-scale grid-connected solar photovoltaic systems including rooftop photovoltaic systems with the combined capacity of up to 100 gigawatts by 2022. See also. References